Now that we've looked at add, modify, and delete functionality provided by LDAP, that's the online tools of LDAP, LDAP add, modify, and delete. Let's look at LDAP search, a means for searching your directory information tree for items of interest. So we'll return to our notes and create a subsection, or a new section, labeling it LDAP search. It's one of the many tools provided with the LDAP suite. And it features ability to search the DIT. It is a command line or shell-based tool, and knowing how to use it will give you insights into how graphical tools such as LDAP Browser and others operate, since they merely call LDAP search. It also supports, for more sophisticated searches, Boolean operators such as ampersand for and, pipe for or, and exclamation for not. And it does all of this using prefix notation, which means you indicate the Boolean operator prior to the terms to be searched. Let's just indicate between parentheses that what each of the symbols mean. This is Boolean and, Boolean or, and Boolean not, to negate searches via prefix notation, which we'll be looking at shortly. So not only can we make simple searches such as object class equals star, which is a wildcard search for all objects in the directory information tree, but we can specify specific branches as well as optionally Boolean operators to further parse or filter the result set. Let's also note that it supports wildcards such as asterisk and plus, which is for internal operations. So we've got a tool that allows us to search our DIT. We'll define some tasks, for example, to search specific OUs for information. Now, before doing the actual search, let's just prefix this with some general usage syntax. In general, we execute LDAP search as follows: the utility name followed by options. Options such as the bind DN, whether or not to use simple authentication, or to be prompted for password authentication using --W, as well as the host to connect to, and the other list of options that we've seen with the other LDAP tools. So it's LDAP search followed by options, followed by the search criteria. Now the search criteria is indicated between quotes, either double or single, and between open and close parentheses. So in between the open and close parentheses, we indicate the attribute. The attribute, if you recall, is simply the field that you're interested in searching. For example, all along we've been searching object class equals star. In that case, object class is the name of the attribute. Star is the wildcard used to indicate any type of object class, whether organizational unit, directory container, inet.org person to reflect a user, etc. So again, we indicate the attribute, a filter operator, and a value. A filter operator is simply one of equal, less than, greater than, less than or equal to, greater than or equal to, or a regex type match. A quick note about filter operators. Again, they include equal to, which is generally used in string comparisons, such as comparing a name to another name, less than or greater than, less than or equal to, as well as greater than or equal to. And the final type is a regular expression match, using tilde followed by the equal symbol. this performs a regex match for approximate results. And tilde equal, or the regex type search, is useful when you don't know the full string that you're searching for. So you specify as much of the string as you know, and the LDAP search utility will try to perform the best match that it can. The value section, again, is either a string and or a wildcard. So value or values tend to be an absolute string, i.e. if we're searching for the user named linuxcbt1 anywhere in any attribute or in a specific attribute such as common name, and in this case we'd simply use equal to perform the string comparison, or using a wildcard such as asterisk. Wildcard is the common, or asterisk is the common wildcard used with LDAP search. So for example, we could search for all users or all common names with the prefix Linux followed by star, meaning any suffix, CBT1, CBT2 through N, or any other match. The asterisk also matches spaces, so if you've got users that you're searching for with a common prefix and a space separating the uncommon portions, the asterisk will still match the space, one or more spaces. So that's a little bit about the general usage, and that is to execute LDAP search using a filter operator and one or more values. And you can combine your searches using the Boolean operators. So you can search for a user with a given first name and a last name, or a given first name or a given last name, or perhaps a given first name and last name, or a given mail address, or a given organizational unit membership. Whatever suits your needs. Now with that said, let's move on to actually searching for information. So we decided we wanted to search specific organizational units. Well, let's begin with our most common search that we've used thus far, and that is to bind to the base DN of DC equals linuxcbt, DC equals internal, followed by a general search for all object classes using the wildcard search. This searches the DIT for everything. There are no restrictions because everything will match, because every object in the DIT has a given object class name associated with it, otherwise it wouldn't be in the DIT. In order to be, or a prerequisite of being in the DIT is that you inherit the attributes associated with a given schema, which means you're tied to an object class. So a search for all object classes returns all objects. So this searches the DIT for everything, returning all objects. And that's the search that we've been performing. Let's open a shell session and indicate the host linuxcbt SUSE2, where we'll see all attributes returned, and we didn't turn on the -x option to authenticate using simple. And there we see all 19 entries, no restrictions. This reflects everything we have in the graphic, including the base DN, the 3 top-level organizational units, and all of the contained users. So no restrictions whatsoever when we indicate object class equals star. Let's just indicate that we want to connect to a specific host and to enable simple authentication. This searches everything. But how about drilling down? Supposing we wanted to search one organizational unit, such as people, as opposed to people, engineering, and sales. Well, we can certainly update our object class match to match a specific OU, or all of the objects in a specific OU by updating the bind or base DN. So here's a variation on that search. LDAP search now we'll zero in on the organizational unit of interest as opposed to the base DN, which searches all sub objects, which means all sub organizational units. by indicating explicitly the organizational unit people. This allows us to drill down and to cut the time required to return the results that we're interested in. And again, the search is still similar. We'll use the object class equals star as our filtration. Now notice just a quick word about this search string. If you notice, it matches what we've indicated in the general usage section. That is, it contains an attribute. The attribute is object class, which means for a given record, let's take a look at the output. Every record has an object class associated with it. So this is the attribute that we're searching for all records. Object class, and it has a filter operator of equal, where it simply matches anything, regardless of the name. So this string set, or this composition of filters, matches the syntax, matches the standard form of attribute, filter operator, and value. Let's try this from the shell to see what's returned this time. Now pay attention to the number of results returned by a search of the entire DIT, 19. This time we should see far fewer entries. And indeed, 6 entries were returned. We can scroll towards the top where we initiated this LDAP search, where we see that instead of searching the entire DIT, it searched the people OU, returning objects within the people OU, the users linuxcbt 2, 3, 4, and 5, and 1, which we added recently after deleting using LDAP modify. So to update our notes, search is OU equals people, DC equals linuxcbt, and DC equals internal specifically. So this is a drill down search. It allows us to search a particular branch of the LDAP tree. Again, instead of searching from the base and all sub objects, which can take a longer time if your DIT is heavily populated, we've instructed LDAP search to go directly to the branch node that we're interested in and to perform an object class search at that level. Now obviously if we can search one OU, we can search another OU in that same way. So supposing we wanted to search the next OU, that's the engineering OU, simply update your search string from OU equals people to OU equals engineering. And this returns 6 objects from OU equals engineering, each object belonging to the organizational unit engineering. Ditto for sales. Let's update engineering to sales. And there are the 6 objects belonging to the sales branch, or the sales tree of the directory information tree. It's really a branch which contains various leaves. So searching specific OUs is easy to implement. Now how about getting a little more specific? What if we wanted to search for only organizational unit type objects? So our next task will be search the DIT for organizational units, or simply OUs. That's a simple search to construct. Again, we need to indicate LDAP search followed by where we intend to bind. Now if you'd like to search the entire directory information tree for organizational units, then specify your base DN as DC equals linuxcbt, DC equals internal, or position it at the root of your LDAP directory information tree, followed by the options that you need to connect to your server and the search criteria indicated between double quotes and double parentheses, open and close parentheses. So now we want to search specifically for the object class organizational unit by indicating object class, which is the attribute matching our syntax, our standard form for LDAP search, setting it equal to organizational unit. This will search the entire tree specifically for objects that wear the type or belong to the class organizational unit. give this a try, and notice the number of entries returned. 4 entries. Makes sense, because if we take a look at the picture before we evaluate the results, the base DN is indeed an organizational unit. It's the base container. Doesn't contain users, but it does contain other organizational units. So this one OU contains 3 OUs for a total of 4 OUs. Now let's evaluate the results. The search terminated, or the end of the string terminated here, and what was returned was an LDIF compliant text stream, which includes where we searched and what we searched for. We searched the base, DC equals linuxcbt, DC equals internal. The scope is subtree, which is the default behavior of LDAP search, which is to search sub-items, sub-containers looking for objects. And that can be limited to the level at which you search if you'd like, but the default is to search recursively. And here are the objects. Here's the base DN. It is of type OU, organizational unit. People, OU. Engineering, OU. And finally, sales, OU. So a quick way to determine the number of organizational units in your DIT is to perform a search at the base of the DIT for the object class equals organizational unit. Now just a quick word about case sensitivity. If we change organizational unit to, let's say, all lowercase organizational unit, the results are still returned. Most LDAP attributes are case insensitive. So you can indicate the attribute name without regard for case sensitivity. It isn't always the case. You'd have to consult the schema. But let's just note that searching or case, most attributes are case insensitive for simplicity. However, consult schema for more details. If you read any of the schema files that constitute any of the objects you're interested in searching, storing, and or searching, you will be able to tell quickly whether or not a given attribute is case sensitive and whether or not the attribute is required. Certain object classes have required attributes, no differently than relational database tables have required fields, one or more. So that's how we drill down for organizational units. Now how about dumping all users across all organizational units? Well, first let's just note searches for OUs throughout the DIT. And let's move on. Our next search will be to find users or objects that are based on the inet.org person object class or schema. So LDAP search, and we can just rip everything from here and bring it down up to object class equals, but not including organizational unit. And this time we'll make organizational or change organizational unit as the object class to inet.org person. Again, no need to memorize this stuff. Take a look at the results that are returned from a prior search of the directory information tree. Here's a search for object class equals star. For the last object, linuxcbt 5, in the given OU, sales, we see that the user is, or the user's record or object is a derivative of or derived from the object class inet.org person. In other words, the fields or attributes associated with this user, linuxcbt 5, with this DN, linuxcbt 5, inherits its fields from the object class inet.org person, which is actually a schema file. So you don't need to necessarily memorize the object classes that are of interest. Just do a dump of your directory information tree and you will be able to determine the defined object classes. So this dumps all users throughout the DIT. Let's give this a try. And there we see 15 entries. Makes perfect sense. The DIT contains 19 entries, 4 of which are organizational units, which means the remaining 15 are of type inet.org person, because that's all we've defined up to this point. So there they are, of type inet.org person, and we can additionally drill down to focus on a specific OU if we'd like. So C will take the entire string and extend the base to zero in on the organizational unit people. And now the search will return users only from the OU people, which should return 5 users. There we see the number of entries, 5. All users only from the people OU as opposed to sales and engineering. Now there are many more types of searches, of course, that we can perform. Let's move on to showing you some other examples. Oftentimes you need to search for specific users. We know that we've created redundant users across the 3 organizational units. The users are named linuxcbt 1 through 5, and there are 15 such users across the 3 OUs. But what if we wanted to search for specific attributes using Boolean operators to zero in or narrow in? So we'll make our third task, use Boolean operators. Boolean operators are very easy to use. They're generally and, or not for negation, but generally it's and or. So as an example, if we want to search for a common name linuxcbt1 and a surname user, we'd construct a Boolean operator. Let's paste what we recently had, and we will search the people OU. That's fine, or we can search the entire directory, doesn't matter. Now we need to update our filter to reflect this new complicated search. Now we did mention when using Boolean operators you should use prefix or. Boolean operators must be implemented using prefix notation. That means before you conduct your search you specify the Boolean operator. So we use the standard parentheses, but we wrap the parentheses with another set of parentheses, and before the search term we indicate the Boolean operator. So what if we want to find the record or records which have a common name linuxcbt1 and a surname user? Simply indicate ampersand as a prefix to what's to be searched between the nested parentheses. Then we go ahead and specify the attribute that's of interest. cn equals linuxcbt1, and if we want to search the surname equals user, include another set of parentheses and specify sn equals user. Now before we execute the search, let's see what this all means. This will be performed or executed against the people OU. We can take any record since the users are named similarly. LDAP search will drill down on the people OU as this recent search has done. It will search the common name attribute for the user named linuxcbt1 specifically. So it's an equal match. It's a string comparison of what we specify, cn equals linuxcbt1, to what actually exists in the directory. Once located, and it will locate this record, it will then compare the surname attribute to what we have specified using string comparison because we use the equal filter. If user matches surname, then this record will certainly be returned. Now, no other record in the people OU contains both a common name linuxcbt1 and a surname user. They all contain surnames user, but different common names, and that's a requirement of the inet.org person schema. That is, the common name must be unique because the common name helps to build a distinguished name, which must be unique throughout the directory. So with that said, let's try to drill down with this particular Boolean search to see what's returned. We'll clear screen, and let's see what's returned. One entry as expected. That one entry is the user linuxcbt1, OU people, DC linuxcbt, DC equals internal. Notice the user also has a surname of user. So we got the record we wanted, and we also see the filter that was specified. This is the Boolean filter using prefix notation. And again, the prefix notation dictates that we specify the Boolean operator prior to the string or strings to compare. So let's just take some notes here. Search is OU equals people, DC equals linuxcbt, DC equals internal for user, or we should write for object with cn equals linuxcbt1 and sn equals user. Now the obvious thing to wonder is about case sensitivity. It's always a concern. So to quell those concerns, let's change the search. We'll write linuxcbt1 in lowercase. We'll write user1, or user that is, in lowercase, and do a dump. Notice, in this particular case, nothing came back. How about switching it? In this case, we made an error. linuxcbt11, we had 2 1s. Now notice, we got the record we wanted. That was an error. So at least the search string in the previous case told us exactly what we did wrong. We had the wrong username, or the wrong common name, that is. So what this tells us is that the search is case insensitive. Note, search is against, or we should indicate this search is case insensitive. So we're able to alter the case without too much concern. Now what about some more searches? We've returned 1 user. How about searching throughout the OU for users with common attributes, or using wildcards, for example? Let's set up a wildcard search. So we want to search the OU equals people for the host. We want to find all users, or all objects, we like to say users, all objects that begin with the keyword Linux and have anything else at the end, and also with a surname of user. Let's see what this does. It's a wildcard, so it should return all of the users in the OU equals people, and there they are. All 5 users contain that particular item. So the wildcard works in that particular case. If we added another user, let's say with my name, then obviously the search wouldn't return my user because it doesn't match. So the wildcard is implemented pretty straightforwardly. Now in this case, we could have omitted sn equals user because we don't have other users yet defined with a different surname. But we just wanted to show you how to combine the different expressions using the Boolean operator ampersand. Now what if we wanted to use the OR, the logical OR? Let's just note wildcard search. So step C, LDAP search, but now we want to change our prefix notation ampersand to pipe. Pipe means OR. The user should contain linuxcbt1 as a common name, or linuxcbt2. This causes only those 2 users to be returned if they exist, or one or the other, if only one exists. Let's try this. There we have 2 results. One user's common name is linuxcbt1. The other user's common name is linuxcbt2. Now we're not only restricted to searching for users or for type inet.org person, we can create any type of condition. We can search for OUs as well as inet.org person types all at the same time by varying the search criteria. We can also compare strings from other attribute types. So for example, if we have a sense for what the user's telephone number is, we can search telephone number is like 203, for example. That's using a regex type search. So let's remove the second string. This is unnecessary at this stage. And we will indicate, we don't even need the prefix notation because we're not ORing or ANDing. We're not combining. However, we are interested in finding the attribute telephone number that is like 203, which should return any item that contains the telephone number 203. Let's give this a try. Now, because this is a numerical comparison, no results are returned using the regex search. However, if we specify the exact number using an equal search, then we see all results because every record contains the same telephone number. However, the regex search would work if we compared it against a typical string field such as common name. So let's try common name equals or is like linuxcbt, and this returns all entries. And let's vary the case, and it still returns all entries. So this search works if we indicate an equal with the explicit value, whereas the regex search works when we compare it to a string field such as common name is like, for example, linuxcbt. So these are some of the types of searches, and if you've got a numeric field like telephone number, you can use less than or the other inequalities to perform your string matches. Now, there are many other things that LDAP search does. If you execute LDAP search help, you'll see the other options. There's a way, for example, to return attributes without values, which is only sometimes useful if you want to redefine other attributes based on existing items and other items, such as continuing if there are errors, as which we've shown you, etc. But by and large, you'll perform searches against specific OUs using criteria such as the following. A given attribute is equal to a given name, a string to be compared, or using asterisk, or combining them using prefix notation using either AND or logical OR to find those bits of pieces of information that you're interested in. So this is the tool to use to help you narrow down that information in the DIT of your LDAP server.